dingleberries.
Podcast divers. Welcome to the Hackaday podcast. My name is Mike Szczys. I'm editor-in-chief of Hackaday.
Hey, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 129. Today we're talking about super clever 3D printing, jigs and registration things, 90s car audio, and smooth LED fades.
We got tons of news this week. Starting off, the U.S. Federal Trade Commission, the FTC, was tasked to put out a report on right to repair a few years ago, and it's finally come through now. The basic news sounds really good. They are coming out in favor of all sorts of different rights to repair, which include not just like the obvious stuff like not preventing you legally from doing it with like DMCA stuff, but also making sure you have access to parts and even making sure manufacturers don't discourage you from taking the device to a non-authorized repair place.
I always wonder about that when you see shops that are not officially branded, but they fix these kinds of phones. Like, why aren't there more of those?
Yeah, and I think part of the answer is it's hard for them to get spare parts. Part of the answer is nobody goes there. I don't know.
I think part of it is like, what are they going to fix, right? One of the things from doing my own repairs, I bought like an aftermarket Google Pixel, or maybe it was a Nexus 5X screen.
Yeah.
And the screen just wasn't as good, right? Like the screen is kind of the whole device. That's like where the rubber hits the road. And the reason that I bought like a not actual screen for it is because I don't think you can get OEM parts for those. And that's part of what this is talking about, is like accessibility to parts, software tools that you have to have a licensing agreement with in order to perform the repair. That's like a difficult barrier that's set up. And, hopefully we can move the ball on that a little bit.
Yeah, and so the point of this report is not making any new laws, but just the FTC is saying, look, we see that this is dysfunctional in the market the way it is now, and if it continues to be dysfunctional, we're going to have to come down with the laws we have already at our disposal. So watch out. And if you read their report with their findings, it's like, when they're talking about a tractor company that uses DMCA to stop people from working on it, we all know who they mean. And so if like I were John Deere right now, I'd be shaking in my boots a little bit. And, if I were Apple, who insists that people go to authorized Apple phone fixers, I would probably be worried a little bit. It looks like the FTC's got their number.
Well, this is the "don't make me come in there" statement, right?
It really is.
It's like, we don't want to have to do this, so shape up.
Yeah, and that's exactly right. And I think that's the right thing to do. I mean, the truth is they have all these laws on the books at their disposal. They could just flip the switch now and say, we're just going to go crazy berserk and start prosecuting everyone. Instead, they're saying, look, here's what needs to happen. Y'all better get on it. We'll see how it plays out over the next 5 years or so. Don't expect to change like tonight. But
no, but at the same time, like if you go the route of just like bringing the hammer down, then you're just going to be stuck in court forever. And that doesn't fix it for the consumer either. Like, this has got to be a way that like we start moving hardware producers towards repairability rather than just tie it up in litigation and hope down the road, a decade later, something happens.
Yeah, I mean, the FTC's job here, they do have authority to prosecute, but their first line of defense is to protect the interest of the consumers and make sure markets are competitive and all of this. And one of the best ways to do that is just to tell the participants, hey, we know what you're doing. Here's what you need to be doing. Shape up.
Also in the news came in late last week. It looks like the group behind the Audacity kerfuffle, Muse, put out another update to their privacy policy that took a lot of the troubling things out of it. Tom Nardi wrote kind of an overview of this that you should go take a look at. The link will be in the show notes. But things like they had a clause in there about sharing data with law enforcement. They had a clause about people that are 13 years old or younger are not supposed to use the software. And I think also they made a change to their telemetry. And again, they're not going to be collecting that telemetry and reporting it back. So these are good changes. The thing that Tom does mention in the closing of the article is that they still have the issue of the contributor licensing agreement hanging over their head, and we're looking forward to some movement on that in the future.
Yeah, this really does look like a good faith attempt to address the community's concerns, and I'm happy about that. A lot of the stuff was just, they must have given free rein to their lawyers to draft kind of the maximally nasty policies, and they took it seriously, when people pushed back on it. The CLA is still a sticker, though, because people who really believe that they wanted the software that they contribute to remain open are going to see this and wonder what they're thinking.
Yeah, and I think on the privacy policy, it's more of an issue of like not reading the room, right? So there's so many huge swaths of people who are just, clicking accept on privacy policies and moving along. I would imagine the legal team didn't even think about who the, target audience for this privacy policy was and just threw the kitchen sink in there, and then people actually read it and complained about it.
Yeah, well, good for them. I think, I think there's a lot of pushback needed on a lot of these privacy policies and default Hoover everything all up data collection methods. And I think we as citizens of the world and the internet need to push back on this as much as we can. And it's really heartening to see that it worked here.
This is a journey into sound.
What's that sound?
What's that sound?
The sound this week is near and dear to my heart. I'm a super big fan of voice synthesizers, early, new, experimental, artificial intelligent, you name it. And that's what we've got going on this week. Why don't you give it a listen?
Well, for example, in producing the word concentration, I have to form 13 different sounds in succession, make 5 up and down movements of the wrist bar, and vary the position of the foot pedal from 3 to 5 times.
So what are those things called? Phonemes? Phenomes?
Phonemes. Yeah.
Phonemes? Phonemes are how you form the parts of speech. And so the earliest computers just put those phonemes together, and then it sounds like the person demonstrating it is using, what's that instrument that goes...
Theremin?
The theremin, yeah. It sounds like the person demonstrating this is using a theremin to control the phonemes. I don't know the answer to this. So are you looking for the project?
I'm looking for the specific voice synthesizer on this, and I don't think anyone except the most extreme voice synthesizer nerds will get this one off the top of their head.
But you could research it for sure.
But I do think there's enough in there that you'll be able to figure it out. And if you've never seen this one before, you're going to learn something really cool along the way. So you'll have a good time reading about it, whether you win the t-shirt or not.
Yeah, so if you think you know what this one is, or you look it up and find out that you do know what this is, go to hackaday.com/podcast, where you'll find the show notes with a link to a form that has your email address, the name that you want said for you on the air when we draw next week, and your answer. We start off the hacks this week with a 3D printer that is being abused for other uses and in the most delightful possible way. Dan Maloney wrote this article called Modified 3D Printer Solders Through-Hole Components. It is a really awesome project that HydroSys 4 came up with. And I think that when I started clicking through and looking into this, it's cool to find out that he is a Tindy seller, and this makes a ton of sense. If you are going to have kind of like small production runs of boards that have a bunch of pin headers on them, you're probably not going to pay for assembly of these boards. But if you find a way around that, manual soldering, it's also going to save you a ton of time. And in this case, the hot end, the part of the 3D printer that would move around and deposit the plastic, has been replaced by a soldering iron tip and a feeder that feeds, I guess, solder filament out onto the tip.
We call that solder.
Yeah, and so this moves down onto the through-hole components. So it would be like an upside-down circuit board with a pin header on the underneath that the legs stick through the holes on the board. And this brings the soldering iron down, touches the leg and the pad on the circuit board, and then feeds in the solder just like a human would, except for it's completely automated and awesome.
I mean, it's all the like little details that make this machine work. And that's really fun to watch when you go through this. It pushes the soldering iron up against both the hole, the pad, and against the leg of the part at the same time. And that really looks like it heats them both up perfectly. You can watch it in the video. It sidles up to it and then it presses a little bit extra hard into it. And that's actually probably really key to success. And then I love just watching the solder like spit out like it's a little mosquito tongue or something. It just goes and then it taps on and then it pulls off and then it lets it cool and then it moves away on to the next one. It's not a fast device, but it's pretty well done.
Yeah, I mean, if you're doing other work in your shop, and in this case, there are these registration jigs that hold the header in place because, it's not attached. So when you turn it upside down, it's going to fall out of the board. So they hold the header in place, they hold the board in place, and then that registers it so that once you zero your 3D printer, it can find where it's going on there. And to do two at once, you put them in there, you do some work, you come back and replace them. Like I said, if you're selling on Tindy, my guess is you make 10 boards at a time, unless they're selling like hotcakes. And so I think it's perfect for that sort of thing. I would like to know a little bit more about like how you get the path planning out of it. Like, is there a way to export it in KiCad and then turn it into the path planning? Like, that is interesting to me and I think would be useful to some people.
It knows where all the solder joints are, right? Like, so it knows where all the holes are, and it looks like it just moves up in between each one of them high enough that it'll clear whatever else is in the way. So I think the path planning is actually pretty simple in a sense.
Well, yeah, I'm wondering how you know where the holes are, though. Like, you have to program that somehow initially.
Yeah, but that's just in the drill file, right? So if you're doing it in KiCad, for instance, you have a drill file that gives you the coordinates of all of the hits for all the holes. And you just use that, and it'll sidle up to all the holes.
Oh, yeah, I didn't think about the drill file at all. Oh, yeah, that's brilliant.
So it's actually really easy, I think. I mean, the tricky parts are in the registration, and the clever bits are the registration jig, like you said. It's also got like a flat screen that's mounted on top of the hotbed on the board that he can then screw these registration jigs down to. So there's kind of like a false floor that he can use for probably swapping out different sets of jigs as well if you're doing different boards. I imagine there's some tuning in getting it spot on for the first set of jigs, but then once you've done that, it should slip right back into place. And so you can take it off, put on a different setup for some different boards. That is slow, you said it, right? Like, it's machine time. If it's slow, you can be doing something else and you don't have to care.
Well, and the fast ones, so this obviously exists because manufacturing of through-hole boards has been around forever. And so they have, wave soldering, which is where you basically put a wave of molten solder across the entire underside of your board. So it goes through upright. But when I was in Belgrade, I got to tour the Microelectronica factory, and they opened up their selective soldering machine so I could watch it live, which is so cool.
Oh, cool.
And selective soldering is where the board is upright, you put your through-hole parts in it, and then you put them into this machine in a jig. And there's like a metal straw that comes up underneath the board that has a fondue fountain of liquid solder coming out of it, and it just goes to each pin. And it doesn't even, like, it can go down an entire row of pins because, there's enough surface tension on that solder that it's coming up like 5 millimeters or something like that.
So it's like wave soldering, but out of a straw instead of with a whole wave.
Yes. And so I put the link in the show notes to a still picture I took of that, so you can kind of zoom in and see. And then I found a really poor quality video that gives you the idea it's from like, I don't know, it's the first video ever on YouTube or something. So it's low resolution and stuff, but it's worth a look. I like it. Selective soldering, cool stuff, but not quite as cool as Hydrosys's project.
My first hack this week is a cool WS2811 trick that makes an LED art installation smooth. This is a documentation of some really nice work Leo Fernankes did on an art project. Basically, he's lighting up rings of white LEDs that are installed around trees. It's on a fairly big garden, and there's a whole bunch of trees with these like glowing LED armbands around them, and they're all synced together. It's a really cool looking effect, but what's really neat about this is his trick to make the WS2811 do something that you're not used to it doing. And in particular, he's got simply white LEDs, not RGB LEDs like you'd usually drive with one of these chips. The game here is that he wants to get more resolution out of it. So he uses essentially one of the color channels to drive a PWM to current converter. So one of the channels controls how much current goes through the LEDs, and then he uses another color channel to do PWM on it. And he builds up a really elegant little simple circuit to do this with just a few transistors in addition to the WS2811. And this gives him effectively 8 bits in the current control and then another 8 bits in the PWM, almost 16 bits of intensity resolution, and that makes the fades on the lights super smooth.
I really like his explanation of this because he walks through the circuit and I can understand the kind of block, devices that he's explaining in here. But boy, I need to do an analog electronics boot camp because I don't have a visceral understanding at all of these structures.
Yeah, don't feel bad on this one. He's doing something really clever by using one of the pins to essentially set an average voltage level and kind of float his circuit up to the, I guess in this case, 12 volt rail. So there's a little bit of tricky analog electronics going on here. You will want to go back and forth through it until you get it if you are watching the video and wanting to do this at home.
I think I need to put it on Falstead and take a look at it. So you could adjust both the current and the pulse width modulation, which further adjusts the current. So it's like you have a constant current source and then you have...
Then you're PWMing it.
Right, and you add better granularity to that, to your adjustability of that current source by then further dividing it into the, I don't know, it's not quite 255 steps, but, let's say 200 steps.
It's pretty darn close. Yeah, that's exactly the gimmick here.
Well, he said he goes through a really interesting thing is he characterizes the chip because he says the data sheet is totally inadequate and finds out that like the last few ticks of that 8-bit PWM value it doesn't actually perform them. So it goes to like 247 or something, and then it stops being able to do anything at that point, which I found really interesting.
Yeah, but you don't see them anyway. Like those are the ones that are like really bright and really a little bit brighter. And you can't see the difference between those two anyway. It's not like at the dark end of things where, the slightest difference really matters. And he goes into actually how the chip does its gamma correction. If you're interested in WS2811, the driver chip, or the 2812s, the smart LEDs, he does a really great dissection of it here, and there's actually some brilliant comments talking about how it works and some real serious research on its gamma correction and things like that. Leo's video is a very clever trick and a great one to get you essentially 6 bits resolution out of an 8-bit controller. Very clever and totally useful. And then there's some other good discussion about these common LED drivers in the comments.
I don't know why I like this next one so much, but if you want to have a server in a server farm, you can go out and rent one. And if you want to have your own equipment in a server farm, you can find a co-location server farm, give them your Blade server, and they will put it in place. But Paul Brown said, hold my resistors, and went and decided to put multiple servers in one 1U server rack case in order to get 5 different computers for the price of one co-location spot. And I bet you've guessed it by now, those computers are Raspberry Pi 4s. So it starts off just with a off-the-shelf case that you would then put your server computer inside of. And Paul immediately goes to work putting a gigabit Ethernet switch inside of there, getting a breakout board for the power supply that's in this, and breaking out those channels to each of the Raspberry Pis. He then gives them solid state storage. So they each have a 240 gigabyte M2 drive that's in its own enclosure. The thing that really got me on this is that he mentioned 16 gigabytes of RAM, and I'm looking all over. I'm like, where's the RAM breakout? Like, how do you get like a SODIMM in here? Do you know where the RAM is, Elliot?
No clue.
It's on the Raspberry Pis.
Okay.
Because you get 4 gigabytes of RAM on each Raspberry Pi, and then you add that together, and that's the specs for your thing. So I kind of got thrown for a loop in there.
I see.
But this is this harkens back to the days when you would like gut consumer electronics and put different stuff in there that used to be much bigger. I'd done it with an Xbox and turned it into a shelf system inside of a DVD case. But this is a little bit more extreme because instead of living in your living room, it's going to go into someone else's server farm, and you're just going to pay them $30 a month to keep it on an uninterruptible power supply and give it a fast internet connection.
Yeah, when I first saw this, I was like, oh, another Raspberry Pi cluster, but it's not really like a performance computing cluster. This is instead kind of a high availability internet serving cluster. And that means, I guess, that these Pis are running much more independently and in parallel to handle big web server loads, right? So they each fail over to each other, and one of them doesn't take the load of serving up his web page when we publish about it on Hackaday. And so I think that's actually a really clever application here. He does say he's not sure it ends up being cost effective in the end, and I'm not 100% sure either, but it's hella cool to do it.
Yeah, there's a bunch of people in the comments yelling at their screens because he spent $800 on this, and they're like, you could get a Mac Mini and put it in there, and it would be just as good. But then you only have one computer.
A Mac Mini wouldn't be just as good. I mean, you could put a high-end Xeon Blade thingy thing in there with a whole bunch of processors, and that would be just as good. But then $800 isn't looking all that expensive.
Yeah, I'm not sure. Like I said, I don't know why I like it so much, but I really do like it.
Low power use.
Oh yeah, we didn't mention it. It has a breakout board for mechanical relays in there, so that one of the Raspberry Pis can turn off the power to all the other ones individually.
Next up, Angus from Maker's Muse. See this hybrid approach to folded 3D printed mechanisms. This is a really neat trick to have in your arsenal. Angus starts off looking at live hinges, and if you've ever made any in 3D prints, you'll have noticed that PLA, after you flex it 10 times, 50 times, it kind of wants to break. It's a little bit brittle. And so his idea here is to incorporate some other material into the 3D printed object to serve as this hinge joint. He starts off inspired by some of those neat textile printing hacks we've seen where you put down a layer of plastic and then you put some thin, maybe wholey, what is that called in English?
Mesh?
Yeah, meshy, fabric-y stuff like your tutu is made out of on top of it, and then you 3D print over that, and because it's got holes in it, the plastic can seal together around it, but then you still have this fabric layer holding all the 3D printed parts together. And that was actually really promising here, but a little bit too kind of floppy for his, I guess, wanting to build a robot joint or something. Funnily enough, what he ends up doing is cutting up some other plastic to embed in there. And that's where it gets really neat because he has this really interesting design flow where he laser cuts out the plastic substrate and then 3D prints registration marks on his 3D printer, slides that thing onto it, and then prints over on top of it. It's this really quite complicated, but once you see it, you'll be able to duplicate it yourself procedure that gives him very precise alignment of this laser cut stuff he's using for the living hinge and then the 3D print on top.
It really is 4D chess, though, because in addition to just the material challenge of getting these things to go together, you have to figure out how to make the mechanism so they'll fold up into the shape and functionality that you expected.
Yeah, sure.
Especially this top picture, which is rack and pinion steering, and the folds make the rack into like a box itself that then the pinion can deform in a way that the two ends remain parallel. It's like a parallelogram. It pivots to the left and right that way. I also really liked that it started with that fabric embedded in plastic. But then I wondered if he eventually will try to manufacture these plastic films so that they can be embedded. He tried it with registration holes. But I just wondered if you cut out a mesh of places that you want embedded in the plastic, you could do like a raft layer that would stay and then like posts that stick up through those holes, then put this down like you would the fabric and then keep printing on top of it and encapsulate it that way. You know, he also says at the end, he's like, I haven't quite figured this out yet. So I know there's more iteration going on and I'm kind of excited because he's so close.
I was looking at this and thinking maybe fiberglass would be an interesting, fiberglass without any epoxy, without any resin. Just the raw glass fiber might be a really interesting thing to 3D print around. He got me thinking about different kinds of hinging materials and... If you're doing a lot of 3D printing designs yourself, you should absolutely pay attention to the way he designs his part with the registration pins in it and then goes back and takes those out and then takes out the part and iterates between those two, because that's actually an incredibly powerful technique. There's a bunch of clever ideas here, and I think he's going to be exploring them all in the future.
Continuing on with the 3D printing theme of the show, this is a project that takes model railroads into the 21st century, and it is completely 3D printed. It is a fully functional roller coaster that is using the same mechanisms as the real thing. So like the way that the cars hold themselves on the track, the way that the tracks are suspended in the air, the way that the cars are accelerated and braking, it is the real thing shrunk down. And that is why I just got that like model railroading thing. The cool thing here is if you think about model railroading, it has a very difficult time changing elevation. So you're mostly working on a 2D design with a little bit of, hill stuff because of the nature of trains. You buy the track already manufactured, so you get it. I think it's brass or some alloy like that has plastic ties together. You send the electricity down that, and you make it run. Well, this is completely from the mind of the inventor on this one. 3D Coasters is the name that the channel goes by. Every part of it, so the track is 3D printed. The spacers for the track, the arms that are holding the track up are all 3D printed. And you get just the craziest of designs because roller coasters have that vertical element, which is what makes them go. This one actually has a cable launcher built into it, which is one of the newer technologies. If you think about the wooden roller coasters that you go up on, there's like a chain drive that takes you up to the top of the hill and then gravity takes it from there. This one actually accelerates you out of the gate. But if you look at this cable mechanism, so he has a winding mechanism that is just driven by like a gearhead motor, and it winds up that cable, and then there's a clutch that is pulled out by a servo, and it releases all of that, cabled up.
It's like a bungee cord or something, right?
Yeah, exactly. So, and releases that into the train car and then sends it rolling. Like, amazing.
Well, who hasn't wanted to make their own roller coasters? Like, that's the ultimate kind of physics experiment in a way, especially those old school ones like you were talking about, where you start up at the top, you've got this much potential energy. What can you do with it to switch between potential and kinetic and make some fun loops on your way down before the thing's left over? And this one's basically the same thing, except it's how much stretch can you put in this bungee cord and whale the thing. It's really fun to watch it go. It's too short a ride. I don't know, in the video it's like a second long. If I were on that, my neck would be like snapped off.
Right, but it's 1/35th scale, so it's like 35 seconds of actual.
35th scale me, my neck would be still snapped off. No, it's really fantastic though.
I'll also put a link in here to one of the other galleries on his Instagram channel that shows these immaculate train car designs, and even puts in there, it was 25 hours to design the train car, 40 hours to print it, and 15 hours of sanding and painting. Oof. I don't know why, but he says he's already on to the next design. I would think once you finish this one, you'd be like, never again.
You had me at 15 hours of sanding.
Yeah. Why are my fingerprints smooth?
Rounding out the hacks this week, I have not one, but two fantastic little small quadruped robots. And I picked both of them because they came out in the same week. No, I want to feature both of them because they're actually kind of opposites of each other in a way. One is got a ton of servos and is a very simple minimalistic design that lets you explore fancy motion. The other one is a very clever mechanism that makes do with very few motors and maybe doesn't have as much room to explore the kinematics, but it's got a nice web server and you can control it from your phone. So starting off with Technovation's Little Quadruped uses many servos. This is a handheld kind of desktop-sized dog-style robot with 3 degree of freedom legs. And that means 3 servo motors per leg, so it can bend the knees, go forward and backward, and then it can also like stick out to the side. And this lets him move the robot in fantastic ways, and you just have to check out his video. He demos it standing on 3 legs and moving its 4th leg in a circle above the table. All of this with MG90 mini servo motors that you can get for like $15 for a 10-pack. Which is good because you need 12 of them, 3 motors, 4 legs, 12 servos to make this thing go. But everything else here is as minimalistic as can be. The 3D prints needed to pull it off are very simple and won't take very long to get done. It uses an Arduino Uno as the brains. There's a lot of room for improvement here in terms of making the servos a little smoother. I think it's got some power supply glitches, or maybe it's servo pulse jitter issues. I'm not 100% sure what it is, but watch that video where it lies back on its 3 legs and it like dangles this other leg around, drawing in midair. This is a lot of sophisticated movement for very little effort.
I only have eyes for the next one.
Then let's get on to it. Next up, Tardigrade Walker is a lesson in 3D printed design. This is Dejan Ristik's design. And like I said, he wanted to do a walker with the minimal number of motors. And it's got this incredibly fancy rouleau wheel gear thing in the center that coordinates among the 4 legs. It's also got a really interesting kind of rotating hip that lets the front legs turn with respect to the back legs. What do you like about this one so much?
Well, I think that Danny really nailed it in that it's the 3D printed design. So there is on the project page a video of Dejan assembling this thing, and that's the best way to look at it because you can see kind of mechanically how every piece of it works. So one of the things that Danny mentioned is it only uses a few screws and instead relies on like snap fit, although there's only, I think, 4 of those snap fit things. But more appropriately, you just use a piece of unmelted filament as like an axle for a lot of the pivot things. And so I looked at that and I'm like, well, that filament's going to fall out. They must melt it in there or something. No, what happens is after you put the 3 pieces, like 2 pieces of a frame, and then in between those 2 pieces of frame, the thing that's going to pivot, you put those together, and then you put your filament in as the axle, and then that whole thing goes inside of the next piece, which creates a frame that covers up the holes where the filament is so that it can't fall out. And he does this like a whole bunch of times as he builds it up. The other thing is there's a cable that goes to the battery compartment that goes up through the center of the entire thing so that you're not rotating, and so that wire doesn't get twisted along it. And then when you get to the circuit board, there's a hole through the circuit board. Like, it's just the forethought that went into this is immaculate.
Yeah, and this is beautifully planned that way, and I agree with you. I love the use of clips here, and that's something you could totally study and take home with you. I think this one, it's going to take a lot of time on your 3D printer, but it's going to be super fun to assemble. And I think if the other one is kind of a study in nerdy motion kinematics and like how much you can do the programming of it, this one ends up being kind of like a remote control walker car. It hosts a web server on board, and that gives you a, turn and walk forward thumb control on your cell phone. It turns the thing into a cool, useful walker at the end of the day.
I also really liked it that there is an extra cable storage thing for the long cables on the hobby servos that kind of slides into place.
Oh, right. Yeah.
And then I have to thank Dejan for this because you get to the end of the video and he turns it on and it goes the wrong direction because he put the motors in backwards. And so then it's already been a time lapse to this point. It's like a 10x time lapse of him disassembling it and putting the motors in the right way. And I was just like, yep, that would be my life. Thank you for including that.
That's super useful to include because it stops you from doing the same thing.
Oh, no. I'd still do the same thing.
Before we leave this, I have to mention again, my favorite small robotic servo hack that I've seen in years is Adam Beckstrom's robot arm achieves amazing accuracy with just servos. He's taking apart hobby servos, putting new brains in them, and adding a little sensor feedback to make them much smoother. It makes them velocity controllable servos. Instead of just saying, go to this position, you can say, go to this position, how fast? And that would add a ton of smoothness to Technovation's little quadruped robot that we saw at the top of this. And I think if you mashed those two up, you would have almost, research quality robotics on your desk for not much more than $100.
I love a good pour over. I don't necessarily like paying for a good pour over, and I don't have the skills to do it myself, but when you can get one and they're just right, you get amazing cups of coffee. And so this is a perfect thing to try and automate. It's all about the temperature of the water and the time that you're putting it over the cone on top of the coffee and how long you're waiting for it to fall into the mug before you put more water in it. And this is something that Alberto is trying to automate with his Cafe Eno project that is all set up to swash the water around just right and get you the perfect pour over coffee. Next up, detecting ripeness in fruit. Another thing that I'm not very good at that I'm hoping that computers can help us at. And we've been looking for the thing that machine learning and AI will actually be able to pull off to make our lives better. And I think if you have machine learning at the supermarket that can give you some kind of ripeness score on whatever you're holding, it's definitely going to make you a happy shopper. I have picked two more instead of just one more because both of these are involved in climbing poles robotically. One of them this week, Lego Pole Climbers, our great study in what it takes to go vertically upwards, is from the Brick Experimenters channel. And as the name told you, it uses Lego to build a climbing robot. But when you look at this, if you've been reading Hackaday for a long, long time, it's probably going to remind you of an article from November 29th of 2010, Climbing Bike Storage Thwarts Thieves. And it is something that you can clamp around a light pole and then you can hang your bike on it and it jets your bike up to the top of the light pole using a remote control, keeping it safe until you come back and reclaim it.
My quick hacks this week start off with Chmod 755's Classroom Surplus becomes Linux powerhouse. He has one of these Smart Response XE classroom devices. I guess they got discontinued. They're super cheap on eBay. It gives you a nice LCD screen and a keyboard. He takes its guts out and replaces it with a NanoPi Neo Air single board computer and turns it into a little tiny Linux handheld. Next up, Retro Game Couch dominate video calls with Game Boy camera webcam. This is really funny. I love the idea of reusing the Game Boy camera as a webcam. He does it here the easy way, which is to take a Super Game Boy, which is a cartridge that would fit into a Super Nintendo, and take a Game Boy cartridge in it so that you could play your Game Boy games on your SNES. He plugs this into an SNES, takes the output of this into an HDMI converter, and then feeds that in as a webcam. The end result is super low quality, super pixely video for telephone conferences, and I think that's hilarious. I think it's not going to be long before someone hacks up the Game Boy camera directly and feeds it in. Last up is PNP Assist, a smart build platform for manual PCB assembly. Nuri Erginer's project here hits an idea that's close to home with me, which is this kind of quasi-automation. You don't need a full pick and place if you're only going to make 3 or 4 of a board, or 10 of them, or 12 of them. In fact, just setting up the reels for it is going to take you more time than assembling the boards, but that doesn't mean there's no room for automation to help you out. This device spins and rotates your board, putting it under a red laser crosshair. It takes as input the part's location file, and it goes from one part to the next, showing you where it is. It's got a little screen that says what the part is. You can rotate it so that it's always at a comfortable angle for you. This project has a lot in it, and you should really go check it out. It's a very clever way to make small run electronics assembly a lot more pleasant, without taking the whole step up to full automation.
We've reached our Can't Miss Articles of the Week. This is long-form content written by excellent Hackaday authors. And this week I've picked a wonderful story that Al Williams turned up. He covered it in an article entitled "Who Flew Across the Atlantic First? The Airborne Boats of 1919." This is a great story about an early effort to get from North America to Europe by flying over the Atlantic Ocean, but not necessarily all in one shot. This is about flying boats, actually. I would call them seaplanes, but it was so early on in aviation that they figured, let's take a boat and let's put some airplane wings on it and see what we can do with it. It started with a design that Glenn Curtiss came up with to build a flying boat that had a 72-foot wingspan. He did this in 1914. And the Navy, looking for, some options on what they could do with getting across the Atlantic, partnered up with him in order to produce the Navy Curtiss flying boat, or the NC. They produced 4 of these, and only 3 of them were actually sent out on the adventure. Each is about 69 feet long with a 108-foot wingspan, which is about the same as a Boeing 727.
If you're interested in crazy early airplanes, you have to check out Glenn Curtiss. This was at the very beginning of airplanes at all, kind of as we know them. Like, this floating boat plane isn't the craziest thing he made. And in addition, for a while, he held the motorcycle land speed record. You have to imagine this was back in the days when motorcycles and airplanes were very similar because they were things with welded frames that had lightweight engines in them. And so there was a huge overlap between the two. If you are ever in upstate New York, you absolutely need to go to Hammondsport and check out the Glenn Curtiss Museum.
So it's interesting the way that they did this is navigation was a huge problem at the time because they hadn't, really needed to navigate in airplanes other than like by landmarks, which is much more difficult when you're out over the sea since there are no landmarks unless you can find an island, that sort of thing. And so one of the things that they did is they partnered up with Richard Byrd, the famous explorer, who was also involved in navigation for aeronautics, and he hooked them up with the bubble sextant. So if you're using a sextant, you need to use the horizon as one of the reference points. And when you're on the water, that's pretty reliable. But when you're above the water in the air, you don't know how high you are above it. You don't know like the inclination of the plane. It makes it a lot more difficult. But you can use a bubble along with your sextant and look at where the natural, I don't know if you'd call it a meniscus or not, but the natural transition there becomes its own horizon, finds its own level, and apparently makes the use of a sextant possible. But they also weren't just like dead reckoning from where they started. The Navy had access to some ships, imagine that, and put 61 of them on this path from where they started. Up in Newfoundland is where they started and made it to the destination, which was the Azores. Now, it was only one of the planes that actually made it. 2 of the others had to land partway through the journey, and that's fine because they're boats, so they float. One of them was picked up by a Greek ship, but the other one had kind of gotten off course, and once they landed, the plane was actually damaged, and they were in kind of rough seas. They weren't able to take off again. They ended up using the tail of the plane as a sail to sail about 200 miles to get to the Azores, which just putting yourself in their shoes is incredible to think about. They didn't have a radio because they got rid of the radios for weight. And then they were off course and they're just kind of in a flying boat in the middle of the ocean. And then what do? And it's these stories that you be a sailor. You
Keep
figure
on
out how to get
trucking.
where you're going. Yeah.
Yeah, right?
Yeah, which is absolutely wild. But it's wonderful little glimpse back to kind of those early days when it was so novel, and it really was like the crackpot adventurers standing this up and being like, we can do this. Like, we can figure out how to make this work. And the point where they had enough redundancy that they did get one of their flying boats to the goal.
My Canvas article this week is How to Modify Your Car Stereo for Bluetooth or Aux-in by our resident car hacker, Lewin Day. Imagine you have a brand new, shiny, used car, and so its stereo system may not be up to today's standards. But you don't want to replace it because that would ruin the look of the control panel. So, if it's a classic, it's got the old dial radios on it. Or if it's, from the 90s, it probably looks tacky, but it's probably nicely built into the console. And you don't want to wreck that. Instead, what you really need is just like a headphone jack or maybe a built-in Bluetooth to talk to it. That's what this is an article about. And I think this was motivated by Lewin trying to add an audio input to a car stereo in a car that he bought from the late 90s. But he goes and walks you through all of the options from, a 1950s classic car to the modern era. How to get your modern audio into the car's existing radio cassette system without doing particularly any damage and with minimal work. And I think that's a really cool topic. It's fun that he breaks it down by kind of technology levels and says, if it's an old one that actually has a potentiometer that all the signal routes through, you're in luck, right? You just plug your signal in straight into that pot and you're good to go. But then as the parts get more and more complicated, they need to switch between radio and CD player and who knows what other inputs. And so there's usually a multiplexer, a mux chip in there, and he walks through kind of patching into the muxes.
Yeah, that one was the most surprising to me, I think, Elliot, because I didn't, I kind of in my mind just jumped from those radios that were primitive devices and like where the volume knob is actually a trim pot.
Right.
To the fully integrated like single chipboards. And I didn't even think about it. And he's got a great picture in here of one of those, crappy single-sided, I say crappy, the substrate I always think of as being crappy, right? What is the substrate called? It's not like FR4, right? It's like particle board or something.
Phenolic. But I bet
Yeah.
I bet you this one's, well, maybe it isn't. Who knows?
Well, so yeah, but
it's a single-sided
to think
board.
that like if you actually have a mux chip in there, like those are not hard to drive. Like you can just look up the data sheet for them and figure out what you're doing. And like that is a fun project that was completely off of my radar until I read this.
And then it gets more fun if you have to hack the chip, because a lot of the new ones, they speak I2C. And so you have to work on the protocol analysis. And that's where things get really hard. He's got a great example that he must have found on the internet somewhere of an Arduino running a TIAC head, but, just trying to convince it to take input from his auxiliary cable. The last possibility he mentions is if you're lucky enough to have one that had a CD changer in the back of the trunk. And actually, my old car used to have one of those. I had a car with a 6 CD changer thing in the trunk. And I never thought hard about how it got the data to and from and the audio to and from. Anyway, if you have a CD changer in the trunk, you may be lucky enough to just be able to unplug it and plug your audio in there. No hassle, no mess. He mentions and includes the diagram for a 13-pin Kenwood CD changer, but mentions that they're not all the same, even if it's got 13 pins.
It is just such a walk down memory lane, and I had just this great jolt of nostalgia in this, like remembering cassette deck head units when CDs came out. So then you would, you'd get that cassette that had the cord that you could attach to the headphone player on like a Discman. But then the disc, you'd go over a bump and it would skip. Remember, like CDs used to skip?
Sure.
And so then I remember like one of my friends had like this long U-shaped arm that was kind of springy that you would then put your Discman on and it would like dampen those bumps.
Right.
On that sort of thing. Man, those were the days.
I always just put it in my lap. But no, the absolute best about those like plug-in cassette things is that the one I had didn't always seat right. And so sometimes it would only play one of the two channels. So you'd only get left or only get right. And you could fix this by, ejecting it and putting it back in, eject it, put it back in until it ends up seating right. Or you could just listen to it that way. And that's when I discovered that the Beatles' Yellow Submarine is tracked in very discrete stereo. And if you listen to the unlucky channel, you just get some tambourine and Ringo Starr singing solo without any of the rest of the music. And Ringo Starr cannot carry pitch in a bucket.
Oh man, he's a listener. Why would you do that to one of our listeners?
Ringo is one of my drum heroes, but my God, his vocals in Yellow Submarine are, try it out if you don't believe me.
That's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment on our show notes, which you'll find at hackaday.com/podcast. You can email us, editor@hackaday.com. We live and die by the tips that you send us, so if you've done something cool or you see something cool, we want to hear about it. tips@hackaday.com. And until next time,
keep on hacking.
And I'm clicking stop. Starp.
Yeah.
Throwing shade at the Ringo.
Yes. Stretch out, dance up and down. That first clap of mine was a little robust.
Perfectly synchronized. As if we were Olympic divers, Elliot.
Yes. Podcast divers.